Hello, and welcome to Intermediate Algebra, Unit 7, Lesson 1, Part 2 of 2. You should have already viewed Part 1 of this lesson, which dealt with simplifying rational expressions, and now we're going to add to that by multiplying and dividing, and then simplifying. So after this lesson, you should be able to simplify rational expressions that require multiplication and rational expressions that require division. So on your guided notes, this is not stated correctly. In the video here it is. When you multiply fractions, you should, if you do A over B times C over D, you just multiply the tops together and then you multiply the bottoms together. That's not quite what it says in the guided notes, so please correct that so it looks like this, because that will be fundamental to what we do here. So again, as a reminder, multiplying fractions is easier than adding or subtracting. We all want to think adding and subtracting would be easier because we learned that first when we were kids, but no, multiplying is easier because you don't need a common denominator. And then you just simply multiply the numerators, or the tops of the fractions, together to get the numerator of the result, and you multiply the denominators, or the bottoms, together to get the denominator of the result. And you can either reduce after you multiply, or you'll see you can reduce, if you factor first, you can reduce before you write the final multiplication answer. So an example, numbers is sometimes helpful. So if I'm asked to multiply 24/5 times 15/16, I get 24 times 15 is 360, 5 times 16 is 80. And each of these has a factor of 40. 40 times 9 is 360, 40 times 2 is 80. So the 40 divided by the 40 becomes 1, and this reduces to 9/2. Now this is a big number to reduce. I happen to be pretty good with a number sense, and I can see that 40 goes into each of them. But if you didn't see that, you might take a while in reducing that. You can reduce before multiplying if you factor each numerator and denominator. So the 24 factors to 8 times 3, the 15 factors to 5 times 3, the 5 it doesn't factor, 5 times 1 is the only way, and then 16 to 8 times 2. Now I had noticed that 24 and 16 both had 8, that's why I chose 8. You could have prime factored these and gotten 2 times 2 times 2 times 3 up here, and 2 times 2 times 2 times 2 here, and 3 of the 2's there would have been 3 2's on the top and 3 2's on the bottom. They would have each reduced. But I did it using the 8. So 8 over 8 here gives me a 1. 5 over 5 here gives me a 1, top and bottom. Then I'm only left with the 3 times 3 over 2, and I get the same answer. So it doesn't matter when you want to reduce. With polynomials, I almost always do it before you don't multiply out the top and the bottom for your answers typically in these. You will just leave everything in factored form. So go to factored form first, reduce, and leave your result in factored form. So here's an example with rational expressions that are made up of polynomials. I have x plus 2 over x minus 2 times the fraction x squared minus 4 over x squared plus x minus 2. I factor the top, so this is multiplied together first, and then I'm going to factor anything that can be factored. So the multiplication is just top times top, bottom times bottom. The x plus 2 is fully factored, but x squared minus 4 factors to x minus 2 times x plus 2. And then at the bottom, x minus 2 is fully factored, but the x squared plus x minus 2 factors to x plus 2 times x minus 1. Now I look to see what I have in common, what factors are the same in the top and the bottom. And when I reduce, I have to reduce either from a beginning or an end to a multiplication symbol. I can't just reduce this x with this x. I have to go x plus 2, and I can stop there because the next thing is multiplied. And down here, I have an x plus 2 between two multiplications that we don't write the symbol, it's implied when factors are written in parentheses. So I get this x plus 2 over this x plus 2 will give me a 1. This x minus 2 over this x minus 2 will give me a 1. and I wrote that out here. You don't have to write that step, but I get x plus 2 over x minus 1 will be what's left. Here's another one that requires us to remember how to factor the difference of cubes. You can look that up, make sure you have that formula handy. So I'm multiplying these two fractions, which are more complicated, or they look more complicated. Remember, you're not going to multiply these out. You're going to factor and reduce and leave in factored form. So I factor the a cubed minus, so I'm going to have, I chose to factor first here and then multiply. So a cubed minus b cubed is a minus b times a squared plus ab plus b squared. That's the top of that first fraction in factored form. The bottom was the difference of two squares, so I get a plus b times a minus b. Now I look at the top of the next fraction, and that does factor to a plus b times a plus b, or you could have written it as a plus b whole thing squared. Sometimes it's nice to write out the things that are squared because then the reducing becomes more apparent. And the bottom does not factor, and I need a 2 there in order for that to factor, so that's prime. And also recognizing that that's a form we get from factoring the difference of two cubes, and I know that doesn't factor any further. That's the other way I know that. So the bottom here, I didn't put parentheses, but we have to remember that the fraction bar acts as a grouping symbol, so it implies that there are parentheses around the bottom. So this bottom, I put it with parentheses over here. I multiplied top times top, bottom times bottom. I just write everything out, string. And you can see the a minus b reduces with the a minus b. The a squared plus ab plus b squared reduces with the same factor below. And I have an a plus b here, an a plus b here. Because everything's multiplied, I can do this. If there was an addition sign here, I couldn't have done any of this. But because everything's multiplied, I can do this. So that leaves me with an a plus b on the top, and it looks like I have nothing on the bottom. When it looks like you have nothing when you're reducing, you have a 1. If you forget to write on the bottom, that's fine, because you just write a plus b. But if this were flipped around, you would have had what looked like nothing on the top with an a plus b on the bottom. You have to remember to put a 1 on the top. It's not a plus b, it's 1 over a plus b if this were flipped. So just for good practice, I'm writing the 1 to replace what I see when everything reduces. When everything reduces, it gets replaced with a 1. So here are a couple for you to try. It might be helpful for you to write out x minus y squared as x minus y times x minus y, or you may be fine with just reducing the exponent. Try these, stop the video, try these, and we'll go through them on the next slide. Alright, you're back. I'm going to trust that you actually tried these, because watching it is nowhere near as good as trying it, even if you don't get very far. So, I wrote out the x minus y in form so I could easily see what I'm reducing. I could have left it x minus y squared and just reduced the 2 to a 1 because there was one factor of x minus y on the bottom. You can do it that way too. So I factored and multiplied in one step in this work here. So I wrote that out, and then I factored the 3x plus 3y to 3 times x plus y. You have an x plus y. The bottom of the second fraction factors to x plus y times x minus y. Now you can see where the like factors are, and that leaves me with a 3 times x minus y in the top over an x plus y in the bottom. If you didn't write the parentheses on the bottom, that's okay, because it's just one group of things, and the grouping symbol of the fraction bar works for that. But if you didn't write it on the top, it's not correct, because that 3 gets multiplied through the whole thing, not just times the x. Second example, second you try it. Again, the sum of two cubes this time factors to a plus b times a squared minus ab plus b squared. The bottom of that first fraction is the difference of two squares. This looks very familiar from one of the examples. And then the top factors to a minus b times a minus b, and the bottom of the second fraction does not factor. So this is what I have, and you can see what I've reduced like factors to become a 1. The things in the same colors are like factors. So I get an a minus b over 1. We don't typically write the 1. So that was multiplication, and you can see that it's not that different from simplifying. The next level of complication in these is division, but it's really not that bad because the first thing you do when you're dividing fractions is turn it into an equivalent multiplication problem. And the equivalent multiplication problem is found by taking this first, we'll look at this formula here, a over b, the fraction a divided by b, that fraction divided by c over d. What you do is you keep that first fraction as it is, a over b remains the same, and then you change the division sign to multiplication. But multiplication and division aren't the same thing, so you also have to adjust this. The c over d becomes a d over c. You swap the numerator and the denominator. We call that using the reciprocal. So you keep the first fraction as is, you change division to multiplication, and you write the reciprocal of the second fraction. And now we have a multiplication problem. We just get top times top, bottom times bottom. So our first step in dividing fractions with letters, with numbers, with letters, with rational expressions is going to be to turn it to a multiplication problem and then do the multiplication problem. So again, here is an example similar to what we started with the numerical example in multiplying. 24/5 divided by 15/16. Last time I think we multiplied. So I keep the 24/5 as it is. I change the division to multiplication, and I write the reciprocal of 15/16, which means I put the 16 on the top and the 15 on the bottom. I factor and reduce, and notice the 8's don't go away this time. They both end up on the top. But I can reduce a 3, and 8 times 8 times 2 is 128. 5 times 5 is 25. Typically with numbers we do multiply out what's left on the top and bottom, but when we're working with rational expressions, with algebraic expressions, we usually leave it in factored form. So sometimes the quantity we're flipping, and a lot of people learn division of fractions by saying keep, change, flip. You keep the original first fraction, you change the sign to multiplication, you flip the second fraction. Sometimes what you're flipping didn't look like a fraction. So anytime you have a fraction involved in a multiplication or division problem, on either side of it, even if it's not both fractions, you need to turn integers into fractions by doing 3 over 1. So if I do 3 over 1 instead of 3, I can see that its reciprocal will be 1 over 3. So if you're trying to flip a quantity that does not appear to have a denominator, it does have a denominator of a 1. So there's like a 1 under this x squared minus 4. So when you flip it, you get the 1 on top and the x squared minus 4 on the bottom. So let's try this one. Divide and simplify it. A lot of people start these by factoring first. I don't recommend that. Rewrite the problem as multiplication, then factor. Because sometimes what happens is you don't notice that there's still a division symbol there and you start reducing, and you cannot reduce until you flip that second fraction and make this multiplication. So I will change this to a multiplication problem first. I kept the first fraction as it is. I changed the division sign to multiply, so there's the keep, there's the change, and now I'm going to flip this second fraction. What was on the bottom goes on the top, and what was on the top goes on the bottom. Now I can forget I even had a division problem. I have a multiplication problem in front of me. I know how to do that. I'm going to factor everything involved. Top of the first one factors to a plus 1 times a minus 1. The bottom doesn't factor any further. The second fraction, a plus 1 on top. Bottom factors to a minus 1 times a minus 1. Now I look for common factors. I have an a plus 1, an a plus 1, an a minus 1, an a minus 1. That all becomes a 1. I'm left with a plus 1 divided by a minus 1. So you turn the division problem into multiplication and then do the problem. Don't try to factor first. So here's another example. I have these two fractions, x squared plus 7x plus 10 divided by y. And that fraction is divided by x squared minus 3x minus 10 divided by y. So I keep the first fraction, I change the division sign to multiplication, and I flip this second fraction. Now I'm going to multiply. Now I'm looking at just a multiplication problem. I'm pretending I don't even have a division problem anymore. Looking at I've made this an easier problem now. When you write down your steps in mathematics and algebra, every step you write starts to make the problem a little easier, and that's the step you work from. You don't go back to the original and confuse yourself again. So x plus 5 times x plus 2 is the factoring of the top of that first fraction. X minus 5 times x plus 2 is the bottom of the second fraction. The y is fully factored. And so I have a y and a y, and here I reduced before I multiplied, because it doesn't matter if I just scribble out this multiplication sign and put the fraction line in, it's the same thing. X plus 2 over x plus 2 reduces to a 1, so I have an x plus 5 divided by an x minus 5. So here's one for you to try, and the words of wisdom are: write it as a multiplication problem first by doing the keep, change, flip, then factor and reduce. So stop the video, please, and try this problem. Okay, you're back. Here we go. So here's my original division problem. It's a little busy here, but you can see that. So I kept the first fraction, I changed the sign to multiplication, and then I flipped this second fraction. Now I factor. The top of the first factor is a plus b times a minus b. I wrote out the a times a, b times b. There's only two of them. It made it easier for me to show you the crossing out. But I could have left this as a squared, and what would have happened was the factor of a 2, the exponent of a 2 becomes a 1 when there's a 1. By the rules of exponents, a squared over a is just a. But this is what you're doing when you do that. A times a, b times b. So I wrote out all that, and now I can see I have an a minus b on the top with an a minus b on the bottom. I have an a on the top with an a on the bottom. A b on the top with a b on the bottom. And I don't have any more like things after I cross those out. It can be a little tricky. You have to write carefully and make sure you can see that there's still an a there when you write your final answer. And so here's what's left, and we typically write the 2ab out in front. You don't have to, but that's typical. And we typically don't put the parentheses underneath because this fraction line implies those parentheses. But I'd be in the habit of, when you have a fraction, you might want to put parentheses around two terms that are underneath, or even two factors, because when you do things in your calculator, you run into problems. All right. So that's it for multiplication and division of rational expressions with simplifying. So you need to practice this and know it well, because we build on this when we add and subtract. Thank you for joining me for this video.